About 2.5 billion years ago, Earth was still a very different world. The skies were hazy with methane and volcanic gases, the oceans were dark with dissolved iron, and the air above the planet contained almost no oxygen at all. Life already existed, but it was simple, microscopic, and fragile. The creatures that lived in this ancient world were organisms that did not need oxygen to survive. In fact, oxygen would have been deadly to them. For more than 1 billion years after life first appeared, Earth remained an oxygen-free planet. The atmosphere was thick with gases like methane, carbon dioxide, and nitrogen. Volcanoes constantly reshaped the surface, and lightning flashed through heavy clouds. Beneath the oceans, microbial life slowly spread across the seafloor and shallow coastal waters. These tiny organisms formed mats and colonies, feeding on chemical energy in the environment. But hidden among these early microbes was a new kind of life, one that would quietly begin changing the chemistry of an entire planet. These organisms were cyanobacteria, simple microscopic life forms that lived in shallow seas and sunlit waters. Unlike earlier organisms, they had evolved an extraordinary ability: photosynthesis. Using sunlight, water, and carbon dioxide, they produced energy and released oxygen as a byproduct. At first, the oxygen they released did not accumulate in the air. Instead, it reacted immediately with the surrounding environment. The ancient oceans were filled with dissolved iron, and the oxygen quickly bonded with it, forming rust-like minerals that sank to the seafloor. Over millions of years, this process created vast layers of iron-rich rock known today as banded iron formations. For a long time, the planet quietly absorbed the oxygen being produced. But the cyanobacteria kept growing and spreading. For hundreds of millions of years, these microbes multiplied across Earth's shallow oceans. Layer by layer, they built strange mound-like structures called stromatolites, trapping sediment and sunlight in their colonies. Day after day, generation after generation, they continued releasing tiny amounts of oxygen into the environment. Slowly, almost imperceptibly, the balance of the planet began to shift. Eventually, the oceans could no longer absorb all the oxygen being produced. The iron had mostly reacted. Other chemical sinks were exhausted. And so, for the first time in Earth's history, oxygen began to escape into the atmosphere. Scientists call this moment the Great Oxidation Event. It was not a single sudden moment, but a transformation that unfolded over hundreds of millions of years. Around 2.5 to 2.3 billion years ago, oxygen levels began rising in both the oceans and the atmosphere, gradually changing the chemistry of the planet. And with that change, the world entered one of the most dramatic turning points in the history of life. To many early organisms, oxygen was toxic. Most life at the time relied on chemical processes that worked only in oxygen-free environments. As oxygen spread through the oceans and atmosphere, it poisoned vast populations of these ancient microbes. Entire ecosystems collapsed. For many forms of life, this was a catastrophe. Scientists sometimes call it the oxygen catastrophe. But while oxygen destroyed many of the earliest life forms, it also opened the door to something entirely new. Oxygen is a powerful molecule. It allows organisms to extract far more energy from food than anaerobic processes ever could. In time, some organisms adapted to this new environment. They evolved ways to use oxygen instead of fearing it. These were the ancestors of aerobic life, organisms that breathe oxygen. This change would eventually make complex life possible. The rise of oxygen also transformed the planet itself. Methane in the atmosphere reacted with oxygen and began to disappear. Since methane is a powerful greenhouse gas, its loss likely cooled the planet dramatically. Some scientists believe this shift may have contributed to one of the earliest global ice ages in Earth's history. The sky itself changed as well. As oxygen accumulated high in the atmosphere, some of it formed a protective layer of ozone. This ozone shield began blocking harmful ultraviolet radiation from the sun. For the first time, life on Earth had a natural barrier protecting it from the most dangerous radiation of space. This invisible shield would eventually allow life to expand into new environments and one day even onto land. What began with tiny microbes floating in shallow seas had now reshaped the entire planet. The air, the oceans, the climate, and the future of life were all different. Over the next billion years, oxygen levels continued to slowly rise. New metabolic pathways evolved. Cells became more complex. Eventually, the first eukaryotic cells, the ancestors of plants, animals, and fungi, would appear. And billions of years later, creatures capable of breathing oxygen would walk the earth. Including us, the air filling your lungs today, the oxygen that fuels every heartbeat and every thought, is the legacy of that ancient transformation. A transformation that began with microscopic organisms in warm, shallow seas, 2.5 billion years ago, when oxygen changed everything.